Hello all, and welcome to the next installment in this algebra pre-calculus series. In this video, I want to talk about two things. We're going to talk about combining and composing functions. If you've been following along with my videos in this playlist up to this point, we've done quite a bit with functions. We've evaluated functions. We've looked at the domain of a function. We've determined what makes a function actually a function and not some equations are functions, some are relations, but not functions. We've talked about the graphs. We've talked about various types of functions, families of functions. But the one thing that each of those discussions had in common was that we were talking about one function. Right? The domain of one function, the graph of one function, evaluating one function, the difference quotient of one function, one piecewise defined function. Now we're going to talk about taking two functions and putting them together somehow. Right? So there's 5 different ways we can do that. The first 4 fall under the category of combining functions, and then the 5th one, we're going to call it something different. We're going to call it composing functions. Now, really, most of what we're going to be doing here is a review, with the exception of the notation. So this is slightly new notation. What you see up here, find f plus g in parentheses, and then parentheses x. Well, that's read f plus g of x, just like we say f of x. So this is f plus g of x. Let me write that right here, this first one. So let's focus just on this first one, because there's 4 things to find here. So let's do addition first. Now there's 4 sort of fundamental mathematical operations we could use to combine functions. There's plus, minus, times, and divide. So let's talk about all 4 of them. And they're going to work exactly the way you would expect them to work. So for the first one, f plus g in parentheses, and then parentheses x. Well, when we see f parentheses x, we read that f of x, right? That's read f of x. We're reading that out loud. Well, this is the same function notation. So this is read f plus g of x. And f plus g of x. So it's still a function. We're taking 2 functions and we're combining them into one new function. So this is what we write. This is the notation. This is the formal notation for function addition. But what this actually means is a bit more visually apparent form. This is just f of x plus g of x. F of x plus g of x. Okay. F of x, that's given. G of x is also given. And so when we're adding these 2 functions together, we get the square root of x plus x minus 17. Now I put the x minus 17 in parentheses initially because that's the g function, but we don't actually need those parentheses, so we could write this in a more simpler way. Simpler just means using less symbols. In this case, square root of x plus x minus 17. Right? There's really not much to do here in terms of making the function. So f plus g of x, in this case, is the square root of x plus x minus 17. So there's basically two parts to each of these problems. There's find each one of these, in this case, f plus g of x, and then determine the domain of each function. So here's the function f plus g. What is the domain of this function? Well, for the domain, I'm going to switch to a different color because this is a part 2 of the problem. For the domain, we have to consider, so let's write this down. We have to consider the domains plural of f of x, g of x, and f plus g of x. And this is something we've seen before. We've talked about the domain of one function. If you want a review of that, you could go back and watch. I think this was the section 1.1, 1.2. In those couple of sections, we talked about the domains of functions. So I'm not going to spend too much time on explaining what a domain is, but let's just find the domain. Well, the domain of the f of x function would be all the numbers from 0 up to positive infinity, including 0. Okay, so that's the domain of f of x. We're basically, at this point, there's only two rules to check, right? The domain is all of the numbers that don't break one of these two rules. And those two rules are, you can't have a 0 on the bottom of a fraction. That's rule number 1. You can't take the square root of a negative number. That's rule number 2. That's the one that applies here. You can't take the square root of a negative number. So for f of x, x can't be negative. So x has to be 0 or positive. That's what this is saying here. 0 or positive. We're using interval notation. The g of x, well, that domain is going to be negative infinity up to positive infinity, or every possible real number. Every real number works in the g function because there is no fraction. So x is not appearing in the denominator of a fraction. And there's no square root in the g of x function. So g of x has no restrictions. And then when we look at the f plus g, the one in the green circle, our final answer for the first part of this question, well, the same issue with the original f of x function. There's a square root of x. So the domain would be 0 up to infinity. X cannot be any negative numbers. So for the f of x, we threw out the negatives. For the g of x, we didn't throw out any numbers. For the f plus g, we also threw out the negatives. So the overall domain is the intersection. Right? So what we're doing is we're taking the intersection of those three. So only numbers that are present in each of these three domains. So the domain of f plus g of x is going to be 0 to infinity. All right, so this is part of our answer. That's the function we end up with when we add f and g, and this is the domain of that resulting function. Okay, so we add and subtract just like we always have been doing so far in this course. Combine like terms. You could use the distributive law. Maybe we factor. We're using the tools that are already in our toolbox. We're just using some slightly new notation. All right, so let's do f minus g of x. And this one's, we're going to run through this a little bit quicker because it's going to be basically the same problem with a minus instead of a plus. Okay, so on the next slide, let's just get a fresh slide here. Okay, so now we've got f minus g of x and determine the domain. All right, so f minus g of x. So same notation. So this is read f minus g of x. And that's going to be f of x minus g of x. All right, we're using the same function for f. That's the square root of x. We're using the same function for g. That's the x minus 17. We're just going to get a different answer as with the first question because we have now a minus between them instead of a plus. So with the first problem, I threw in those parentheses, even though they weren't necessary. It's just good habit. In this problem, the parentheses are actually necessary because we're subtracting all of the g function, right? This is the g function, the x minus 17. So we have to subtract both of those terms. So that's going to give us the square root of x minus x plus 17. Just be careful with your signs. We're subtracting the x, that's the minus x. We're subtracting the minus 17. So two minuses make a plus. All right, so then our final answer is going to be the square root of x minus x plus 17. And the domain is going to be the same. The domain is going to be the same as in the last problem for exactly the same reason. Right, you look at the domain of f, the domain of g, and the domain of our answer, and we take the intersection of all three of those. All right, so that's plus, minus, times. F times g of x, and then determine the domain. Okay, so this is read f times g of x, and this is equal to f of x times g of x. Okay, this is the formal way of writing it. This is the one that I think makes more sense looking at it, the f of x dot g of x, or f of x times g of x. So that's f of x, and we're multiplying that by the g of x function. And we don't need a dot there. We could just say square root of x times x minus 17. Now let's look at the domain a little bit differently. We're going to get the same answer, but let's just another way of looking at the domain of the function. So one way we could look at this is sort of visually. We could have done the first two this way as well. So let's say this is negative infinity to positive infinity. And here's our number line, right? 0. We could put a 0 in the middle, positive numbers on the right, negative numbers on the left. And we'll do one domain for the f function. Let's just say f. One domain for the g function, and one domain for the f times g function. Okay, so for the f function, 0 to infinity. Okay. Same as with the last two problems. With the g function, there are no restrictions, so the domain is all real numbers. And then our answer, f times g, well, that is the same as f. It has a square root of x, so no negatives. No negatives there. So when I say the intersection, I'm looking at where the three of these overlap, where all three domains overlap. So the domain of f times g of x is, again, 0 to infinity. 0 to infinity, including 0. So this was the first part of our answer. That's the function, f times g. And then the domain of that function, 0 to infinity. So far, 3 for 3. The three domains were the same. Okay, so let's start with a fresh slide and look at the fourth one, the final one. Division. We did plus, then we did minus, then we did times, and now we'll do divide, and then determine the domain of the function. Okay, so this is read f over g of x. Right, this is the f over g function. We make this by combining the f and the g with division. So that's f of x over g of x. So that's the square root of x divided by x minus 17. And that's it. There's our function. That's f over g of x. We put the f on top and the g on the bottom, and there's our new function. But now, when we look at the domains, and I'll take a visual approach again this time. It's one way of looking at it, not the only way. But we've got these number lines represent all real numbers. Right? We want to know if the entire number line is the domain, only part of the number line is the domain. So let's see if we could figure this out. Negative infinity to positive infinity, 0. Okay, so the first two are already done. It's the same. We've been using the same functions for each problem. So the domain is of f, no negative numbers. So 0 and everything to the right. The domain of g is everything, all real numbers. Now the domain of f over g. Well, the numerator has a square root of x, so that means no negatives. So no negative numbers, that means only 0 to infinity, but there's an x minus 17 in the denominator. Right, so that's telling us x cannot equal 17, because if you replace the letter x with the number 17, you get 17 minus 17, which is 0. You can't have a 0 on the bottom of a fraction. So the top is saying x can't be negative, and the bottom, so we'll say x can't be negative, and the bottom is saying x cannot equal 17. So this little red arrow I have here on the bottom, let me get rid of that, because somewhere to the right of 0 is the number 17. And that's a bad number. That's a bad number for this problem. So it gets an open circle because x cannot equal 17. So x could be any number from 0 to infinity except 17. So when we put these three together, we could say the domain of f over g of x is, well, it's starting at 0, right? Because we got rid of negative numbers. So starting with 0 up to 17, but then we have to stop at 17. 17 is not included, so we use a parenthesis, not a bracket. The parenthesis is what we use for an open circle. The square bracket is what we use for a closed circle. And then union, that's like the word and. So all the numbers from 0 to 17, not including 17. And then all the numbers above 17 to infinity. So those curved parentheses on the number 17 tell us 17 is not included in the domain. All right, so in this particular problem, the plus, the minus, and the times all gave us the same domain. But division, we have a slightly different domain because we had to throw out one of the numbers. We had to throw out 17. Okay, so there's 5 ways we could put functions together. We could add them, subtract them, multiply them, divide them. And the 5th way to combine functions, or to take 2 functions and merge them into one, is using what's called a composition of functions. Composition of functions. So this is where we're going to take something we've done before. Evaluating functions. All right, so that's what we're using here, evaluating functions. So I'll talk about this notation in a moment, that open circle between the F and the G. That's new, right? We haven't talked about that in any of the previous videos. But we have talked about evaluating functions. So let's just say the G of, I'll use the G of X function as an example. Evaluate G of 2. Evaluate G of 2. So the word evaluate means replace. Replace your variable with something else. So G of 2, so this is read G of 2. That means replace X with the number 2. So G of 2 would be 4. Instead of X squared, it's 2 squared minus 3. All right, instead of 4x squared minus 3, we get 4 times 2 squared minus 3, which is 4 times 4 minus 3. 4 times 4 is 16, and 16 minus 3 is 13, right? So that's a very quick review of what it means to evaluate functions. The word evaluate, another word for that is replace. We're replacing the variable in our function with something else. Okay, so I'm going to erase everything here on the right because I kind of need this board space. Okay, but this was hopefully a familiar quick review. We've done a lot of evaluating functions so far. So now, let me actually write the title here because this is important and also new. Composition of functions. So we have add, subtract, multiply, divide, and compose. The 5th one, composition of functions. This is evaluating a function with another function instead of a number. Instead of saying G of 2, I plug 2 in for the X. Well, I'm not going to use a number here. I'm going to use a different function. I'm going to use another function inside of there. Okay, so now let's start with the notation because that's the most important. I'm looking at this first one. So that little open circle, let me use a different color. Let's use let's go with a red. That little open circle right there, that's the word of. That's the notation for the word of. So we have 2 ofs when we read this out loud. This is read F of G. F of G. And then when there's an X here, that's read F of G of X. F of G of X. Now, if we think of a function as being an input-output machine, where we say, okay, well, we could have this set of numbers. This is called the domain of the function. And then let's say I'll put the G function here. And then this would be the range. I'll be more specific. The range of G, the domain of G. Right? Now what we do is we take an X value. I use the number 2. that goes into the g function. And we just saw that if you plug in the number 2, the number 13 comes out. And that's what the g function does. It takes the number 2, squared it, then times it by 4, then minus the 3, gave us 13. What the composition of function is doing is saying, okay, you got 13 from the g function. Now take that 13 and put it in the f function. Take that 13 and put it in a different function, in this case, the f function. So the range of the g function, the outputs of the g function, that's actually going to be the domain of the f function. The f function is 3x minus 3. So I'm looking at these two functions, these two specific functions we're working with, f and g. So the f function takes a number, multiplies it by 3, and then subtracts 3. So 13 times 3 is 39. And then when you subtract 3, you get 36. So 2 goes into the g function, becomes 13. And then that 13 goes into the f function and becomes 36. So it's a two-step function. Now there's another way of writing it, which I think is easier on the eyes, right? Something that when you look at it, it makes a little bit more sense. And another way we could write this is f of g of x. F of g of x. So what that means is inside the parentheses for the f function, there is a 4x squared minus 3. Right, we're taking the entire g function, right? This is the g function. The 4x squared minus 3, and we're taking that entire thing and we're plugging it into the f function. So I'm going to just put this arrow up here, and we're saying, okay, this whole thing right here is going in for that x. So instead of 3 times x minus 3, we're going to get three times 4x squared minus 3 minus 3. All right, so that 4x squared minus 3 is going into the f function in place of the x. Now we simplify the way we have done previously. Distribute, collect like terms. Should just be a couple of steps here, so we can multiply through three times 4x squared, 3 times minus 3. So that's 12x squared minus 9 minus 3. Right, 3 times 4x squared is 12x squared. 3 times a minus 3 is a minus 9. There's still a minus 3 there. So that's 12x squared minus 12. Right, and that's it. We're taking something we've already done, evaluating a function or plugging something into a function or replacing the variable of a function with something else. And now we're just using functions to plug in rather than numbers. Okay, now this final answer, now we could do stuff with this, but we don't, it's not in the sort of the context of this problem. We could factor that. We could factor out a 12, and we could use the difference of squares formula, and we could say that's 12 times x minus 1 in parentheses times x plus 1 in parentheses, but we don't have to in this case. And it doesn't say factor your answer or anything like this. It's just plug the g function into the f function and simplify. Okay, so that's it. That's it for f of g of x. Let's start with a fresh slide. Let's look at the next one. Just switch the order. Instead of the first one, f of g, this is g of f of x. The first one, the first function that's listed is the outside. The second function that's listed is the inside. So when you see g little circle f parentheses and then parentheses x, that's g of f of x, or g of f of x. So that means the entire f function, is going into each x. In this case, there's only one. Each x in the g function. So the first problem, we took the entire g function and put it into the f. Now we're taking the entire f function, putting it into the g. So that's g of, and the thing we're plugging into the g function is the 3x minus 3. That's f. So f is going into the g. Okay, so instead of 4x squared minus 3, which is the original g function, 4x squared minus 3, we're doing 4 times 3x minus 3, and all of that squared minus 3. So the f is going into the g. And that's it. That's it for the sort of the new component of this problem. All right, so we have new notation. And that's basically it as far as what part of this is new. It's the notation. The evaluating and the simplifying, those are things we've already talked about. So anything times itself, or anything squared, means that thing times itself. So 3x minus 3 times 3x minus 3. So we're done with the composition part. Now it's doing a little bit of algebra to simplify. So for 3x minus 3 times 3x minus 3, we could use the FOIL method. First times first, outer times outer, inner times inner, last times last. So we still have a 4, right? We still have a minus 3 on the outside. But first times first would be 3x times 3x. So that's 9x to the second power. Outer times outer, we have a 3x times a minus 3. That's minus 9x. The I is inner times inner, so that's negative 3 times 3x. So that's another minus 9x. And then last times last, the L in FOIL, a minus 3 times a minus 3 is a plus 9. So we've got 4 on the outside. We've got 9x squared. 9x minus 9x, that'll be a total of minus 18x plus 9. Still have a minus 3 on the outside. Now we got to distribute that 4. All right, we want to do as much as we can to simplify this. So 4 times 9 is 36. So that's 36x squared. 4 times 18 is 72. So that's minus 72x. And again, 4 times 9 is 36. So that's plus 36. And we still have a minus 3. And then finally, we could combine these two numbers, a plus 36 and a minus 3. That'll give us a total of a positive 33. So, and this is good that it's our last step because I'm about out of room here at the bottom right. So that's 36 x to the second minus 72x plus 33. The part of this problem that was new, this new topic of composing functions, it was just this first step. The rest, I'm going to write the word review here because those steps are things that we've covered previously. Okay, so that's f of g of x, g of f of x. Now the next two are using a number. It's f of g of 1 and g of f of 1. I'm going to go back to that image I wrote on the previous slide. Because we basically already did those last two problems. I just used a different number. I used the number 2 instead of the number 1. But let's do it again. And we'll use f of g of 1. I'm going to do both of these on the same screen. Okay, so f of g of 1 means f of g of 1 I'll use red for the inside. So f of g of 1, which means we want to work inside out, right? So g, if we ignore the f part, if we ignore the blue part, right? We ignore the blue part. What is g of 1? What is just the g of 1 part? What is that? Well, that means we plug 1 into the g function. G of 1 means instead of 4x squared minus 3, it's 4 times 1 squared minus 3, which is 4 times 1 minus 3, which is 4 minus 3, which is 1. Okay, so it's a two-step process. It's a two-step process, and that was the picture I drew earlier. I said this is the domain of the g function, and here's the g function right here. And here's the range of the g function. And I think I used orange. We used the number 2 in the previous example, but the number 1 goes in to the g function. And actually, in this case, the number 1 comes out. In this case, it's the same number in and out. When we plugged in 2, which I did a couple minutes ago, 2 went in, 13 came out. So it's just a coincidence here that the same number is the input and also the output. Okay, that's what we've done so far. And now we take that 1 and we plug it into the f function. That's what f of 1 is. So f of 1 means we plug 1 into the f function. So that's 3 times 1 minus 3. which is 3 minus 3, which is 0. So f of g of 1 is equal to 0. So this process of composing functions, this is going to be important in the next thing we do. So in this particular class, this is going to be section 1 point, this is section 1.7. 1.8 is coming next. To do section 1.8, we're going to have to do this as part of the, as part of the work. Okay, so we plugged 1 into the g and then that into the f. So that was f of g of 1. And in the other direction, g of f of 1. I'm not going to draw this diagram that I have here in black. You don't have to write that part down. I mean, that's more of a visual aid for this demonstration. But g of f of 1 means g on the outside, f on the inside. We're doing f of 1. What is f of 1? You could look at just, look at that by itself. What is that? What is f of 1? Well, let's plug 1 into the f function. That'll give us 0. We replace the x, so say, I'll use the same color as before. F of 1 is, instead of 3x minus 3, it's 3 times 1 minus 3, which is 3 minus 3, which is 0. So that was like step 1. We plug 1 into the f function, and now we get an answer, and that answer, 0, we plug that into the g function. So g of 0 means we take the g function and replace the x with a 0. So instead of 4x squared, it's 4 times 0 squared minus 3. Anything times 0 is 0, so that'll be 0 minus 3, which will be minus 3. So g of, make sure it's an open circle, because that's our notation for composition. G of f of 1 is equal to -3. So I'll highlight this up here, because we actually did both of these problems on this slide. Okay, so now the last thing, like we did with plus and minus and times and divide, we also talked about the domain of each of those. Same thing here. Now we have to talk about the domain of f of g of x, or the domain of g of f of x. We don't talk about domains when we're plugging in a specific number, just when we're dealing with the functions. Okay, so here is a new problem. We have 2 new functions. We have f of x is the function 5 over x plus 5. And then we've got g of x is the function 8 over x. I had to bring in fractions at some point, just to cover all of our bases. So we're not going to do f of g and also g of f. We're just going to do one. What is f of g of x? What is f of g of x? And then we're going to talk about the domain. There's two parts to this problem. Okay, so I'll erase the domain. We'll get to that in a minute. F of g of x That means f is on the outside, g is on the inside. So the g function, instead of writing g of x, we know what g of x is. It's 8 over x. So that is going into the f function. So instead of 5 over x plus 5, we're replacing the x with 8 over x. And that's it. There's the answer. We replace the x with the g of x. Now, this is not the final answer because this is not simplified. Just like you would probably not want to solve an equation and say your final answer was x equals 6 over 10. You wouldn't want to give 6 over 10 as a final answer because it's not simplified. You would say, okay, well, mathematics, we generally, conventionally want to give our fraction, if it's a final answer, in simplest forms and in reduced form. So that's 2 times 3 on top, 2 times 5 on the bottom. The 2's cancel. And you would actually say the answer is 3 over 5. That would be considered correct in terms of your final answer. So final answer, no unreduced fractions. Another sort of agreed upon standard is for your final answer, you can't have fractions inside of fractions. So here we have a big fraction, 5 over, and then we've got a little fraction inside of a bigger fraction. So that's a problem. So we've got to simplify now. So our composition part, our f of g of x, that part's done. Now it's do a little bit of algebra to simplify. So let's see what we could do here. We got 5 over 8 over x plus 5, right? What I want is one fraction over one fraction. Because if you have this, no pluses, no minuses, if you have one fraction over one fraction, then you can rewrite that as keep, change, flip. You could take division and rewrite it as multiplication, but that only works if you have a single fraction on top and a single fraction on the bottom. Now, single fraction on top is no problem because you could take the number 5 and write it as 5 over 1. So now we've got a fraction on top. But on the bottom, we've got 8 over x plus 5, which I could write 5 over 1. Right? So you're good. You're good on top. Now you just have to combine these two fractions on the bottom into one fraction, and you can't do that because they don't have the same denominator, so you can't add yet. You need a common denominator, so we could take this second fraction and multiply by x over x. So we get what we're doing here is getting a common denominator between those two fractions on the bottom. So then we've got an 8 over x plus a 5x over x. So now we could combine them. So we've got on top 5 over 1, that's a fraction on top. On the bottom, we've got 8 plus 5x, all divided by x. We've got fraction on top, fraction on the bottom. Now keep, change, flip. So the way we divide a fraction by a fraction is to rewrite it as multiplication, multiplying by the reciprocal of the fraction on the bottom. So top times top, 5 times x, bottom times bottom, 1 times 8 plus 5x. And this would be our final answer, right? In simplified form. We no longer have a fraction inside of a larger fraction. Okay, so now let's talk about the last thing I'm going to talk about in this video is the domain of this composition of two functions. Since we're taking a number from the domain of g of x, that's going into the g function. So x value goes in. What comes out? Well, if an x goes in, the output is a y value, but we're not going to call it y. So let me actually make this a little bit bigger. Domain of g. Here's the g function. So the number that goes in, we call that an x. The number that comes out, we call that a y or a g of x. Remember, they mean the same thing. This is the range of the g function. Right, so y is the same as f of x or g of x or whatever you call it, the function values, the y values, call them f of x, g of x, or h of it, whatever function you're working with, whatever the name of that function is. So I'm not going to put a y here, I'm going to put a g of x. Okay, so then, now that output goes into the next function. So that's f of g of x. So you get f of g of x. All right, so that's how this two-step function works. The inside function gets used first. If you're doing f of g of x, you use the g function first to get an answer. And then that answer goes into the f function. So you're doing f of g of x. So you only have to check these two domains. You don't have to do the f, the g, and the f of g. I'm going to go back a few slides when we did plus, minus, times, and divide. Right? We looked at, for the overall domain of f plus g, or f minus g, or f times g, or f divided by g, we had to look at the domain of f and the domain of g separately, and the domain of the thing you got when you combine them. We had to look at all three. For compositions, we don't have to look at all three. We have to look at the inside function and the composed function. You don't have to look at the domain of the outer function. So, only two number lines here. One for g. One for f of g. Those are the two functions you have to look at. Right, let me highlight them. Let me highlight them. We need to look at this guy right here. and this guy right here. Right, just the inside function and the final answer. So for the g function, x could be any number except 0, right? Because you have 8 over x. So you can't replace x with the number 0, but you could replace x with any positive number. Also, any negative number. But 0 doesn't work. And then if we look at the f of g function, the 5x over 8 plus 5x, well, that's a fraction. The bottom can't be 0, so 8 plus 5x cannot be 0. 8 plus 5x cannot be 0. So solve for x. What can x not be? Well, if we subtract 8 from both sides, we'll get 5x cannot be negative 8. So minus 8 from the left, minus 8 from the right. Divide both sides by 5. And you'll get, nope, not 5. You'll get x cannot equal negative 8 over 5. So for the g function, x can't be 0. For the f of g function, x can't be negative 8 over 5. Negative 8 over 5, I don't know, somewhere to the left of 0, there's a negative 8 over 5. Somewhere over there. It's a negative number, so it's to the left. So you could use in that function any number to the left, any number to the right. The overall domain is the intersection. So any numbers that were thrown out for the g are off limits. Any numbers that were thrown out for the f of g are also off limits. So both of these numbers are out. Both of those numbers are out. So the domain would be any number from negative infinity up to negative 8 over 5, not including negative 8 over 5. We could also use any number from negative 8 over 5 to 0. So we'll do the union. Let me I don't want to squeeze this in to the end. So let me write this a little bit smaller. Negative infinity to negative 8 over 5. Negative 8 over 5 is off limits, so that's out. Then we could look at all the numbers in between. Negative 8 over 5 up to 0, but not including 0. Then we can look at all the numbers to the right of 0. 0 to infinity. So this would be the domain of f of g of x. So these problems are starting to get complicated because we're taking quite a few different individual discussions that we've previously had, sort of merging them into one problem. Okay, so that's it for this discussion on combining and composing functions. Again, in this video, thinking short term, the important one is the f of g of x. Short term, because that's what we're going to be using in the very next topic. So if f of g of x doesn't make sense, when you're in that next section, it's going to cause some issues. So please spend a little bit of time with this. It'll be worth it when we get into the next topic, which is inverse functions. Inverse functions. All right, that's it for this video. I hope this was helpful.